Hey guys, here's a little extra practice for your quiz. So number 1 is asking whether or not the equation is linear. If it is, write it in standard form. It's just like the warm-up that we did today. We do know that it is linear. We know it's linear for a few different reasons. So the x and the y are not together in the same term. There's no x or y in the denominator. There's no absolute value, anything like that. So yes, it is linear. So it says, if yes, write the equation in standard form. So I'm going to do that. So I'm going to take x over 3 is equal to 15 plus 4y. Let me give myself a little more room, make this a little smaller. Okay, x divided by 3 is equal to 15 plus 4y over 2. To clear out those denominators, I'm going to multiply everything by the least common denominator, which is 6. If I cancel, this will leave me with a 2. That'll leave me with 3. And then, of course, I just need to multiply the 6 by 15 because it doesn't cancel. So I've got 2x is equal to 90, because 6 times 15 is 90, plus 3 times 4y gives me 12y. Remember that standard form is ax plus by is equal to c. So we're pretty close to standard form. All that needs to happen now is that 12y needs to be moved over to the other side. So I'm going to subtract 12y from each side. So my final standard form is 2x minus 12y is equal to 90. For number 2, it asks which are linear. Okay, A will not be linear, thanks to that exponent right there. B is linear even though it's got the 2 y's, because the 2 y's can be combined. The important thing is whether or not there's an x combined with a y in the same term, and there's not, so B is linear. C is in standard form, which we know is linear. D is not linear, thanks to that x, y that are paired together in the same term. E is just like the one we just did. It can be converted to standard form, so it's linear. F is not going to be linear. Excuse me, thanks to that y in the denominator. G won't be, thanks to that exponent. And finally, H won't be, thanks to that absolute value. For number 3, it's asking us to find the x and the y intercept. So we know to find the x-intercept, I'm going to substitute 0 in for y. So instead of 4 times y, it's 4 times 0. So really that leaves me with 2x is equal to 16. Divide both sides by 2. X is equal to 8. To find my y-intercept, I've got to replace the x with 0. Divide both sides by 4. Y is equal to 4. So if I were to graph it, my y-intercept is here at 4. Ooh, the x-intercept, we didn't quite have enough room over there. We're going to pretend there's an 8 over there. Connect it. And because it's a linear equation that does not have a horizontal or a vertical line, we know that the domain and the range are both all real numbers. For number 4, we did realize a slight problem on here, but I didn't realize it until after I'd already made my copies. So the chart should be 2, 7, and then 12 right there for the numbers. Just FYI, because that's going to kind of mess something up. Okay, so for number 4 through 7, it asks to find the slope of the line that passes through the ordered pairs. Because 4 is in a table, I'm going to do it the good old-fashioned look at the rate of change way. So my y's are all increasing or decreasing by nothing, so their change is 0. And the x-coordinates are increasing by 5. So remember that the rate of change is your delta y over your delta x. So 0 over 5 is equal to 0. Number 6, I'm just going to look at the 2 intercepts to find the slope. And draw my little box right there. So my up and down change is going to be 4 because the intercept is a negative 4. And then my change across, in other words, my run, okay, so here's my rise. My run is 6. So I'm going to place 4 over 6, which simplifies to a 2 over 3. And I can see that this is increasing in slope, so it's a positive 2/3. For number 6, I'm going to use the formula y2 minus y1 over x2 minus x1. So I'm calling this coordinate 1 and I'm calling that coordinate 2. So that means if I substitute, I'm going to do 8 minus 6 in the numerator. Then I'm going to do negative 1 minus a negative 2 in the denominator. So 8 minus 6 is 2. Negative 1 plus a positive 2, because that's really what's happening here, is going to be a positive 1. So my slope is 2. Last but not least, for number 7, it says when you're skating up a ramp, you rise 5 feet for every 8 feet that you skate forward. So your rise is 5, your run is 4. That means your slope is going to be 5/8. For number 8, it says find the value of r so that the line passes through the pair of points has a given slope. So first of all, I'm going to set up my y2 minus y1 over x2 minus x1. So because as usual, I choose that to be coordinate 1 and coordinate 2, I'm going to do r minus 3. Oh no, I'm sorry. I just subtracted a y minus an x. R minus 5 for my numerator, and then negative 3 minus 3 for my denominator. So I need to figure out, so r minus 5 over negative 3 minus 3, that is the same thing as r minus 5 over negative 6. And because the problem tells me that it is equal to 3/4, I'm going to set it up that way in my equation so that it's r minus 5 divided by negative 6 equals 3/4. So now I've just got one of those fraction problems that we've been working on quite a bit. And you guys can cross multiply all you want. You know it's not my jam. I'm going to go ahead and just multiply by my least common denominator to clear out those denominators. So I'm going to multiply both sides by 12. And if I cancel, that'll give me 2. That'll give me 3. And actually, let's go ahead and put in that negative from that 6 in there too. Let's multiply by negative 12. So that this will be a negative 2 and a negative 3 that we're multiplying by. And then that way it'll cancel out this negative here in the denominator. So once I multiply through, I've got negative 2, which I'm going to multiply by r minus 5. So that's going to be negative 2r plus 10. And then that negative 3 is going to be multiplied by positive 3, which gives me a negative 9. I'm going to subtract 10 from both sides. That leaves me with negative 2r is equal to negative 19. Divide both sides by negative 2. R is equal to 19 over 2. Hey, it says graph the equation, then state the slope and y-intercept. So I've got options for what I could do. I could go ahead and graph by intercept since it's in standard form, but this one's less than ideal to do that because the 3 and the 4 coefficients don't evenly divide in the 8. So even though you're welcome to do intercepts if you want, personally, I'm going to convert this thing into slope-intercept form. So I'm going to subtract 3x from both sides, which leaves me with a 4y equals negative 3x plus 8. Divide everything by 4. So my y is now isolated. And then this negative 3 over 4 becomes a negative 3/4, x for my slope. And then the 8 divided by 4 becomes my y-intercept of 2. So I'm going to do graph my y-intercept right there. Because it's a negative 3/4, I know from there I'm going to go down 3. Then I'm going to go over to the right, 1, 2, 3, and 4. And because I kind of ran out of room going that way, I'm going to go backwards. Up 1, 2, 3, 1, 2, 3, and 4. So here, not such a straight line, sorry about that. But there is my linear function, and my slope is -3/4. My y-intercept is a +2. Last one, a construction crew needs to rent a trench digger for up to a week. Equipment rental costs the company $40 a day plus $20 insurance costs to rent it. Okay, so first I'm going to write and graph the equation to find the total cost. So I'm going to write the equation. So it says my total cost, and it doesn't tell me what variable to use for cost, so I'm just going to use C. So my cost is equal to $40 per day plus the $20 non-refundable fee that it's going to cost you to get it. So that is the equation that I'm going to use. To graph it, I'm going to start with my y-intercept, which is the 20, right there. And my rate of change is 40. So that means it's going to increase $40 every day. So it starts off at 20 bucks because even though I get in real life, you're not going to pay $20 to rent it for no day. You still have to have the y-intercept accounted for in the problem. I know that doesn't seem very realistic. That seems kind of silly. If you don't rent it for any days, why would you pay the $20? That's kind of the way the graphing works here. So we do need a coordinate over 0 days. So no matter how many days, it's a $20 non-refundable cost. So if you rent it for 1 day, 1 day would be 40 times the 1, of course, which is 40, plus 20, which means 1 day would cost you 60. Then the next day would cost you 100. So you see your rate of change is increasing by 40 every time. Again, not the best straight line. Sorry about that, guys. Okay, so I've got it graphed. And then find the total cost to rent a digger for 2 weeks. Well, that would be $40. 2 weeks is 14 days. So that would be $560 plus the $20 you got to pay for insurance for a total of 580 days.